Hello everyone, this is video 14.4. We're going to be looking at constructions with straight edge and compass. I'm going to assume that a lot of you have done this in the past. I'm also going to assume that it's been a while. It's been quite a while. So if you remember a lot of this, really familiar with having done this before in high school, some of this may be sort of repetitive or unnecessary. Like I said, I'm going to assume that most of you uh, don't remember a ton of this, so I'm going to go through it kind of as slowly as reasonable. So let's get started. We're going to be doing constructions, like I said, with a compass and a straight edge, and so we should probably define what those two things are. The compass that we're going to be using is not the one with the little needle that points north. That's not what we're doing. Not that kind of compass. This compass is sort of like an upside down V. It's got a little point that usually you put in one place, and that needle or that point helps it kind of stay in one place. And the other side has a pencil or a pen or something that allows us to sort of draw an arc or a full circle. Um, so that's what we're going to be using as a compass. And then a straight edge can be any straight ruler, anything that's going to help us make a straight line. Now, if you use a ruler, one thing to be careful about is that we can't use the ruler to measure. So if you are going to use a ruler and it's got inches or centimeters along the side, it's sort of against the rules to use that straight edge uh, to measure things. We can use the compass to measure something. And so if we're given a line segment, you can take your compass and open it up or close it to where it's as open as that segment is. You put one point on one end point of the segment and then open or close the compass so it's on the other end point of the segment. And now your compass is as big, is opened up to that length. And so we can duplicate those lengths. So we can measure with the compass, but not with the straight edge. So it's just sort of a restriction. Now, it's up to you to decide if you actually want to do the constructions or not. If you have a compass and a straight edge, then that would certainly help. If you're not very familiar with this process, if you don't remember, or by somehow you didn't have to do them the first time through in high school or even in middle school, you may want to actually go through and do the constructions. Uh, Otherwise, there's a free utility called geogebra.com, and the website's right there, which is what I'm going to be using to do all the constructions as well. There's a little bit of a learning curve for figuring out how to use the compass tool and how to make lines, line segments, and rays. But once you figure out how to do those two things, then the rest of it pretty much makes sense. There's tutorials and things you can see. It has a lot of functionality that we're not going to do, right? You can even do translations, reflections. You can do the transformations and rigid motions that we looked at earlier in the chapter on there if you want to. I'm not going to require it. I'm not even necessarily going to suggest it, but it's just an option that you have if you want to duplicate some of these constructions. So the constructions that we're going to be looking at are really going to be using the idea of congruent triangles. And really, to be totally honest, we're going to be constructing the same figure. We're going to be constructing the rhombus that we saw in the previous section. Um, so we're going to be constructing these and then using those congruent triangles that are sort of embedded in that rhombus to show some sort of congruency. And so you'll see what I'm talking about here in a moment when we look at our first construction. One piece of this that maybe hasn't been explained very explicitly is once I construct congruent triangles, I know that every corresponding part, every corresponding pair of parts in those figures are going to be congruent. So as an example, we've got these two triangles here, and these are the same two triangles that we saw on a previous slide. And so this AB is marked to be congruent to DE. So we know those two are congruent. And this BC is marked to be congruent to this EF. So we know those are congruent. And then this angle is congruent to this angle. And you can put little marks on the angles as well to show these. So we saw on the previous slide that these are congruent by the SAS, side angle side postulate or criterion. So the point I'm getting at here is that once I know these two triangles are congruent, now I also know that this side is congruent to this side. Now, that wasn't given as part of the condition, but once I know these two triangles are congruent, then this follows from that. I know this as a result of that. And then once I know these three sides are congruent to these three sides, then I could also, sort of reprove it by side, 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 which doesn't make an awful lot of sense because you've already proven it. There's no point in reproving it. If I look at this angle here between the 2 and the 3, then we know it's congruent to this angle between the 2 and the 3. So I could mark that with 2 marks. And then this angle between the 1 and the 3 is going to be congruent to this angle between the 1 and the 3. So I know all of the corresponding parts, all the parts that are in the same place, are going to be congruent to each other as well. This wasn't explained very explicitly in previous sections, and we're going to need it for what we're going to be talking about in this section. So I just wanted to take a second and sort of define that. So we're going to go through two constructions, kind of go through very briefly how to do these constructions. I'll say this at the end, but I'm going to say it now as well. You do not need to memorize these constructions, all right? So the point of kind of going through this is that you see them and hopefully you understand the application of congruent triangles and the rhombus that we looked at the end of the last section to see how these constructions work. So if you were presented with the construction, you should be able to understand why it works, but you don't need to memorize it. You don't need to do it. It's beneficial if you do, but it's not going to be a requirement. So just to let you know, sort of like, your requirement in this process. All right. So we're given a line segment here, this line segment AB. It has a little label here, F, so we could talk about it as segment F, but I'm just going to call it by its endpoints, AB. And what I would like to do is bisect this line. So we're going to be doing the bisecting a line segment. And what that means is I want to cut it in half. I want to find the midpoint of this line segment. So there's going to be some point, probably pretty close to this F, that cuts these exactly in half. Now, one way that we could do it under normal circumstances would be just measure it with a ruler and then divide that length by 2. But remember, we can't do that for a couple reasons. I mean, the biggest reason is that it's sort of forbidden in this process. But the idea is that the ancient geometers wanted to use tools that were reliable. And, if that endpoint was somewhere between marks on your ruler, well, now you're guessing. And now you're going to take half of a guess, you get an even worse guess. It's not very precise. If we use the compass and straight edge correctly, then we should get that precise point. We won't know how long the segment AB or how long the half segments are, but we do know that they are exactly half. Those two segments are going to be exactly half. So we're going to do this by construction, and really we're going to use it by using this idea of congruent triangles. So the first thing we're going to do is construct a circle at A that has AB as a radius. And so you can see this first circle, it's labeled as circle C here. So this first circle here has A as the center, and then has AB as the radius. And then this circle over here, which is labeled as D, but the D is sort of like in between the two circles, so it's not very clear, so I'll write D over here. Circle D has B as the center and AB as the radius. So these two circles have the same radius. And hopefully then that all radii in the circles are congruent, they're of equal length, and so hopefully you're starting to see a lot of congruency using this property of circles that all the radii are the same length. So now the next step is going to be to put points where those circles intersect. So I've got this point up here, C, and I got this point down here, D, and I'm going to connect them with a line segment. And so I'm going to connect these 2 points together. So the only thing I've done here is put this point E in where line segment CD intersects AB. I put this point in. And I put these little dashed lines in so we can kind of see a little bit more clearly what's going on. Now, I know that AC is congruent to AD because they're radii of this circle here on the left. And I know that BC and BD are also congruent to each other because they are radii of this circle. But even better than that, I know that those two circles were constructed with the same radius. And so I can actually get rid of this line and this line because all four of these are the same length. They're all congruent to each other uh, by construction. I constructed them to all be the same, so I know that they're the same. Uh, Now, what I have now, this quadrilateral with all four sides equal, I know I have a rhombus. This is the definition of a rhombus, remember? So I've got my quadrilateral with four congruent sides. Now, remember, we want to be careful we don't say four equal sides because four equal sides would imply they're all the same thing. So congruent lets us know they're equal in length. So we know that all these sides are congruent. As we saw in the previous section, once I have this rhombus, then I know I have a lot of things equal. All four of these triangles are going to be congruent. And so once I know that they're all congruent, I know that these are all right angles. And I know that this segment is equal in length. It's going to be congruent to this segment, which is what I wanted to show. This is what I wanted to find. I wanted to find the midpoint that bisects this segment, and now I've found it. Now, you might notice that I've also bisected this segment, which isn't really useful. That wasn't really what I set out to do, but it is an extension of what I wanted to construct. And so I have a nice little byproduct here that I've also bisected CD. All I really wanted to find was this point, and I found it, but I've also found a whole bunch of other stuff, which is kind of nice. The second construction that I want to look at, I'm not going to go through the whole thing like I did the first one. I'm just going to kind of walk through it very quickly. And in this case, it's the angle bisector construction. And so if the line segment bisector was finding the midpoint of that line segment, then the angle bisector is going to be cutting that angle in half. Although it's not really a point, it's going to be the ray that cuts that angle in half. So I've got this, and I'll do it in red here. So I've got this original angle here, BAC. So BAC. And so what I'm going to do is I'm going to take this point C here. I'm just going to take one of the 2 points, and I could have chosen B, but I chose C because it's closer to A, and so it helps keep the circles a little bit smaller. So I'm going to put my point at C, I'm going to measure out to A, and I'm going to construct this circle here with center at C and radius AC. And so this has a radius of AC. Now, I've put my compass at that point, so I can put the needle at A and mark off D so that AD and AC are the same length. And so D is constructed to be the same length as AC. And now I'm going to put my point here and then construct this circle here, which is centered at D and also has a radius of AC. So both these circles are constructed to have the same radius. And so now you can hopefully see where we're going with this. We've got this, 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 this. We've got our same rhombus from before. And by the same reasoning as before, all these radii are equal because they're of congruent circles. I constructed them, both these circles, to have the same radius. So we know that all the radii are equal. Now, in this case, I'm not going to connect C to D and cut this line segment in half. I'm not worried as much about cutting the segment in half. Remember, I'm cutting the angle in half. And so what we have now, we know that this angle is congruent to this angle. These triangles are congruent. And so more importantly, I know that this angle is equal to this angle. And so since I know those two angles are equal, each one is half of the larger angle, I bisected that angle. I've cut that angle in half, which is what I set out to do. All right. So just as a reminder, don't memorize these constructions. That's not the point of this section. Like I said, you're not going to be asked to replicate these constructions, at least not for this class. They're good to know, and really you're constructing the same object, both ways. So if you can do one effectively, you can do the other, although you're using the rhombus for different points. The idea of this was just to kind of go through some constructions, have you see some constructions, and also use the ideas of congruent triangles to understand how these constructions work. So again, you don't need to do them, you don't need to memorize them, you don't need to replicate them. It'd be good if you could, but it's not necessarily a requirement. We're not going to do much more with these. This section really is just sort of about applying the ideas of congruency from the previous section, applying it to something so you see the utility. So for your checkpoint, we have constructed 3 rhombuses now. We did 2 in this section and then 1 in the previous section. So using that rhombus, can you figure out how you might construct a rectangle? So any given rectangle. So think about what the properties of a rectangle would be. And then how could you get all of the parts of a rectangle? So if you were given the short side and the long side of a rectangle, how could you possibly construct that rectangle? So I'll let you think about that. If you have any questions about this problem or any other problem from this section, as always, bring those questions to class and we will get them answered. All right, thanks.